All right, so like I said, my name is Jeff Anderton. I am the owner of Teaching High School Chem, and I'm excited to have y'all here for our first webinar. I'm trying to stream this to Facebook, but it really seems like it's slowing it down. So I think I'm going to, because I want to stream this first one to Facebook, but I want to basically say the rest of these webinars are going to be, the rest of these workshops are going to be simply for those who register. It just makes it a lot easier for me keeping track of who I am, because I really want to be able to interact with y'all more than just simply give you information. So with that, let me get started. Let me turn off my little window here. All right. So today we're talking about how to plan and pace your chemistry curriculum. And so first of all, I want to start off with me. Like I said, my name is Jeff Anderton. Notice the T instead of an S. Just got to be a little bit different there. I grew up in the suburbs of Atlanta. I grew up in Marietta, Georgia. I'm the middle of three boys. My mom's a retired science teacher. She taught middle school. She taught 7th grade, which I just can't even imagine doing. And then I got my chemical engineering degree from Georgia Tech in 1999, and decided I didn't want to be an engineer. Decided that my passion and my gifts were more for teaching. And so I got in my education degree from Kennesaw State. With a focus on secondary science and a specialization in chemistry. And so I graduated from there in 2001, and I've been teaching chemistry ever since. I've taught in a small private boarding school for kids with attention deficit disorder and other minor learning disabilities. I've taught in small schools here in Mississippi. I've taught, a wide variety of subjects, and I've also been an administrator through my career. So I've kind of covered a lot of it all. So like I said, I live in Mississippi with my wife and our 2 kids. I've got a son who will be 6 in July, and I've got a 15-month-old today. So you can also be thinking of my wife, who's got the kids out of the house right now, so that we can do this workshop today. And so I am excited to get rolling here. And so I started teaching high school chem last summer. Really last spring. I had a passion and a desire. I've always had a desire to help teachers, to equip teachers. That's what I'm about. And so that's what I want to offer you. And so to me, that's what I want us to get going and focusing on, is just how can I help you? And so that's why I started doing that. I actually left the classroom. I was going to go back in the fall. But really just felt that this is where I needed to spend my time. So I've been out of the classroom for the last year, developing a membership site and a course and other things to just try to help equip teachers to teach chemistry and to teach it well. And so with that, let's get into planning and pacing. So when it comes to planning, when you're trying to plan out your year for chemistry, I think it's really important that we begin with the end in mind. And I think a lot of times it's easier to kind of go backwards from that. And for me, I like the illustration of building a house. That we need to kind of take, and I'm a big fan of illustrations, and I think they're really helpful for helping kids understand things, and adults for that matter. So for me, the first question we have to ask is, well, what type of house or what level of house are you building? Are you building a mansion? Are you building a 3-2? Are you building a little cottage? What are you building? And what that looks like in our class is, what are we building towards? Like, what is the purpose of our class? Is the purpose of your chemistry class to get your kids graduated because they needed to graduate? Is the purpose of your chemistry class to prepare them for college chemistry? Or is the purpose of your chemistry class to prepare them for AP Chem? To me, all 3 of those are different things, and all those are 3 different levels. And they change how you plan your course just a little bit. And so I think it's important to have those in mind. Also in your mind could be something like, trying to meet state standards. And to be honest with you, state standards are a mile wide and an inch deep. They try to have you cover everything. And if you try to cover everything to the same depth, you're not going to get very far. You can cover everything in the state standards, but you got to pick and choose. Some things are going to get very glossed over. Like for me, example, nuclear chemistry is in the state standards. but it never gets more than a day or two of my time. I cover it very quickly, and I hit it and I move on. Equilibrium is one of those things that I think that's more of like an AP Chem or a college Chem topic. I hit it. I introduce Washotway's principle, but I don't spend a whole lot of time there. And so we need to kind of keep that in mind. So what type of building are you building? So for me, I am all about preparing kids for college chemistry. That's my focus. And I'll kind of talk a little bit about the other two as we go along, but that's where I'm coming from. That my goal is to have my kids to be able to, if they choose to, and they have a degree where they have to take chemistry in college, that they can walk in and not get creamed. Because I've tutored enough college chemistry kids that I know that college professors cover nomenclature, naming everything, reactions, and moles and stoichiometry and conversions. They cover all of that usually in the first week, maybe week and a half. And then they move on expecting kids to remember that stuff from high school. And so that's why I think I need to think those things are my priorities. I call them the big three: nomenclature, reactions, and stoichiometry. They are essentially the main walls of the house. They are the load-bearing walls that carry all of the weight of the entire course for chemistry. And so I put my attention there. And so I start with what I think is most important, and then I'm going to plan from there. So most important to me is nomenclature, reactions, and then moles and stoichiometry. We then need to take a moment to look at, well, what do we need to have to prepare the students for those key components? So for example, in order to do moles and stoichiometry, you have to know conversions. In order to do stoichiometry, you have to know reactions. In order to do reactions, you have to know nomenclature. And then before that, going back, in order to do nomenclature, you really need to know how the periodic table is structured and how to use it. And in order to understand the periodic table, you need to understand atomic and quantum theory. And so that's kind of the foundation to me, kind of your intro to lab safety lesson, your intro to chemistry lesson, and then jumping into the foundation: atomic theory, quantum theory, quantum mechanical model being in there, and then periodic table. I consider those kind of my foundation. And so they're important, but they're not the most important. I spend time on them, but I try not to spend too much time on them. And then everything else to me is finishing touches. Heat and reactions, states of matter, intermolecular forces, gas laws. Then add, acids and bases, solutions, equilibrium. All of those things are extras, for the lack of a better way of saying it. And how much depth they get honestly varies from year to year. My pacing and my planning is never exactly the same every year. And we'll get to why that is in a minute. But so for me, I'm preparing my kids for college chemistry. So I'm focusing on the big three. And I devote more of my attention to the foundational things like atomic theory and periodic table. And then this other stuff is, I'm not saying it's less important. I'm just saying, well, it is somewhat less important, but it's not unimportant. These things are important. They need to be discussed, but they're going to get a little less of my priority in terms of planning. Now, all of this comes to bear on, what are we building? If we decided we're building for even AP Chem, and if you're building for AP Chem, then you need to talk to the AP Chem teacher and talk with them about what skills they want those kids to have walking in the class. Or if you're doing for just graduation, then I just tone it down and just get the kids through. But once again, focusing what you think are key skills that they need to know. But what are we building? Are we building content, or are we building understanding? Is the house that I'm building covering my chemistry curriculum, or is the house I'm building my students' understanding of that content? And for me, it's all about student understanding. And I think that's critical. And you also kind of have to decide which students. Are you trying to just get the kids who are, your honors kids? And if everybody else makes a C or D, you're okay with that. Some teachers have that mentality. My mentality is I try to teach every willing student. I have had students who have failed my class, but they failed because they did not try. They did not put forth the effort. I did everything in my power. And I know I had a clean conscience when I put an F on the report card because they were not willing students. For me, I'm trying to get student understanding, and I'm trying to get every student who wants to learn, I want them to learn. And I'm going to work with them. That may not mean an A. There are some kids who are just B students, and that's okay. But I want them to get a B when they should get a B and not a C or a D or an F. And I want to help every willing student. And so when we make that decision that what we're doing is we're focusing on students, and when I make that decision that I'm focused on students, and when I make the decision that I'm going to focus on every willing student, then what happens is that dramatically affects how I do pacing. Because planning's great, but it's actually the pacing where everything comes to fruition. And so for me, I believe in what I call student-driven pacing. That it is my students who determine how fast I go. Now, not explicitly, I don't let them know that they're deciding it, but I'm using them as my foundation as I go along. And the reason why I think this is so important, and once again, going back to the house model, if you're building a 2-story house and you try to build the second floor before you finish the first, like finish framing the first, that's not going to work very well. The house is not going to be able to sustain the weight. If you haven't finished all the load-bearing walls and you try to put in a second floor, that house is going to collapse. And I think a lot of times we as chemistry teachers, we get sucked into that trap. We try to move into reactions before our kids understand nomenclature completely. And we wonder why they have so much trouble with reactions. Or we try to go into stoichiometry before they really understand mole conversions. And we're confused and frustrated that they're not getting it. Because chemistry, I think more than the other sciences, is really built on prior knowledge. That you have to lay that foundation, and you have to lay it solidly and lay it well in order to have the kids ready to go. And I think that's critically important. And so, like I said, so if the foundation's weak, then anything built on it will be compromised. And that's why I've got next week's workshop on, dealing with students with weak math skills, because that's often a weak foundation issue. And we as teachers have to somehow address that, deal with that. And I've got strategies and ways that I deal with that I'm going to share with y'all next week. But that's one of those areas that we've got to look at. So along those lines, if we have power over this, we need to make it a priority. If we have power over their knowledge, and before we move on, then it's our responsibility to do something about that. Because here's the deal. I've heard people complain, but it's going to cost me an extra, couple of days. Yes, it may. Like for example, when I do nomenclature, what's ionic nomenclature specifically? I break it into sections. I do metals and nonmetals first, binary ionic. I do metals and nonmetals first. And I make sure my kids understand how to do metals and nonmetals first. They can do just the really basic. They can do sodium chloride, magnesium oxide, potassium sulfide, whatever. They can do those basic metals and nonmetal ionic names and formulas. Then I move on to polyatomic ions. And then I make sure they understand polyatomic ions. And then I add transition metals. And then when I've done that, I pull it all together with the covalent nomenclature that we've already done, and that's to do all of it together. If I move into polyatomics before they are comfortable with metals and nonmetals, I'm setting myself up for a headache. It is better that I take an extra day or a half day or 2 days to make sure they are really well set so that I'm not just absolutely pulling out my hair later with them and they're just not getting it. Like I said, so a few more days of doing nomenclature is going to make teaching reactions easier because kids are going to be able to read a reaction and know what those things are without having to sit there and look at a periodic table that's got the names on it and try to figure out what Na3PO4 is. If we spent enough time with nomenclature, they should go, oh, that's sodium phosphate. It may take them a couple of seconds, but they should be able to get that that's sodium phosphate. And so they should be able to move with that. I've put a lot of extra time on conversions before I get to moles and stoichiometry. And I don't even do conversions at the beginning of the year. Most chemistry books have conversions in chapter 1 or chapter 2, and I don't teach it then because it's not being used then. It's not being used until we get to moles much later. And so what I do is I save it. I teach it right before I teach moles. And I teach conversions right before I teach moles. And then when I lay that good foundation, I make sure they can do conversions backwards and forward. They can do 1 step, 2 step, 3 steps. They can convert from any given unit to any other unit. Then I can add moles in it, and they're like, oh, this is easy. It's amazing what taking a little extra time to lay that foundation will do later. But that's part of pacing. You've got to be willing to sacrifice a half a day or a day as you're going along in order to save yourself times and headaches later. But in order to be able to do that, we have to be able to supervise the building process. We need to know when the foundation's done. When have kids learned it enough that I can move on? And this first thing I want to share is also just with kids facing chemistry. You're going to have lots of kids walk into chemistry who have been doing relatively well in school, and schools come easy to them. And all of a sudden they reach chemistry and they're like, oh my goodness, what is this? And they struggle for the first time. They don't get it immediately for the first time. They actually have to sit and think and work on it. And they're going to freak out because they think, wait, I should learn this the first time. But learning is a process. Did you learn how to teach immediately? Were you a master teacher in your first year? The answer is no, by the way, if you're a first-year teacher. First-year teaching is all about surviving and just getting through it and learning. The second year of teaching, you finally get to apply, the things you learned in school. And then the third year, I think you finally kind of get in your rhythm and you feel comfortable and you kind of get a little bit more of that mastery of teaching. It's a process. It takes time. And our students are oftentimes impatient with this. And we need to remind them of this, of like, hey, if you already knew chemistry, you wouldn't be in my class. But you don't know chemistry, and that's why you're here. And we're going to learn it. It's a process. A classic example of this for me is when I'm doing quantum mechanics. Quantum mechanics is weird. Quantum mechanical model is weird. And literally, I tell my kids as I start going through it and I'm trying to explain to them, Heisenberg uncertainty principle and Pauli's exclusion principle and, Hund's rule, and I'm trying to explain all these things to them. I make a comment. I usually say, all right, guys, give me 2 days. If you're confused after day 1, or give me 3 days. If you're confused after day 1, that's fine. That's where you're supposed to be. If you're confused after day 2, that's okay. I'm down with that. If you're confused by the end of day 3, then let me know and we can work on that. Because it's amazing for students how freeing it is for them to go, oh, wait a second, I'm not supposed to get this immediately. It just brings down that anxiety factor. And I'm going to kind of get to some other things that I think that bring down the anxiety factor as well and help kids with that. So as we build, we have to assess as we go along. Now, in a traditional model, that would be this: homeworks, quizzes, labs, tests. I hate grading with a passion. And I hate writing comments on things that kids may or may not check. And so I change my model that I don't focus on these things. What I do, I use them. What I use is I use class time and classwork. And here's what that looks like for me. I teach roughly, this is when I'm doing skill-based things like nomenclature, reactions, stoichiometry. I teach generally about half to maybe 2/3 of the class period. I'll lecture for that long and then I'll stop. I hand out a classwork assignment And then I walk around and I check on my students while they're working on the classwork assignment. Sometimes it's a homework assignment. If it's a longer homework assignment, I'll give it to them to start with. But then I'm walking around the classroom and I'm assessing where my kids are. And I'm able to get more feedback from them and give more feedback to them. Somebody just asked, how long are my class periods? My class periods are 15 minutes. So I'm teaching out of that 15-minute mindset. If you're teaching out of a block mindset, I would split this in half. I teach for a little bit, do some classwork, teach for a little bit, do some classwork. And that would kind of be my model of how I would do that. But I would still do this classwork model that for me, I find, and it took a little bit of training for my kids to learn to do this well. But I'm walking around, I'm not at my desk. I give them this work and I'm walking around. I check on my weak kids first and kind of get them started. And then like my medium kids, those middle kids who get really frustrated when they make a small mistake, I check in on them second. And I'm kind of like, hey, you made one small little mistake. Don't freak, because they'll just freak out and be like, oh, I don't know how to do this. I can't do this. I'm so stupid. I'm like, no, you're not. You made one small little mistake. Let's fix that. Hey, try the next one. And then when they get the next one, I'm like, hey, see, you got it. Because, I love it because I'm getting an assessment of where they're at. They're getting help from me or from their other peers. I allow peer coaching as long as it's on task. I have to really work with my smart kids to not give the other kids the answers, but to actually help them through the process. But that's what I'm trying to do is I'm trying to give them feedback and I'm trying to give them that assessment because what I found was I was giving kids their homework assignment. They were going home. And then we were spending half the period going over the homework and fixing all the mistakes they did and trying to fix all the wrong practice they had done because they had been practicing it wrong. And now they got all this wrong stuff in their head and I got to go back and undo that and then teach them the right way to do it. And I'm spending half my period the next day doing that. So I've just shifted it to the front. So now I've shifted it to the front end and I get to help them before they do their homework. I get to make sure they have a good foundation and know how to do it before they go home and practice. And I find that it dramatically cuts down on the amount of homework I've got to grade for accuracy. It gives me a great understanding of where they are. Where are they struggling? Because I can be walking around the room and I'm like, oh, wait, they're not getting this point. Now I'll pause them from working, go back up to the board, reteach a little bit to reemphasize a point or to show a common mistake people are making. And then I go back and, then I get them working again and I go back and assess. Because this allows me to assess where they're at without having to grade a bunch of homework, without having to grade a bunch of quizzes. And it just frees me up in a lot of ways that I think is really, really helpful in terms of being able to assess where they're at and what's going on. And the other thing here that's going to help with your pacing, because here's one of the things, this student-driven pacing, it's kind of front heavy. You spend your time at the beginning laying the foundation, and it's going to allow you to go faster at the end. So it's going to feel like you're going slow at first. But if you create an environment where kids know that learning is a process, and they're okay with that, and they stop freaking out all the time, and you create a safe environment, with classroom management. Classroom management for me for years was so hard. I hated busting down on kids because I thought it was between me and that kid. And the big shift for me came when I realized that classroom management wasn't about me and that student. Classroom management was about that student and the other 20 in my classroom or other 30 in my classroom. That I was allowing one student to get all the attention and dominate, and the other 20 or 30 were suffering. And when I could see that classroom management was about me protecting the other 20 to 30, then I got a lot better at it. And I was able to put kids out in the hall and have them sit there and deal with them later, and things like that. That was a big shift for me. But it made my classroom safer. It made my classroom a place where kids felt safe to learn and to try and to work on those things. And somebody asked if I do grades on the class practice. I do sometimes. Um, Sometimes I do, sometimes I don't. I mean, that's also how I grade homework. It drives the kids crazy, but I don't grade every piece of homework. I don't have that much time. I like having a life outside of school. And so one of the things I do is I tell the kids like, hey, every homework you get or every classwork assignment you get is fair game. It could be that I'm going to check it for completion. It could be I'm going to check it for accuracy. It could be I don't check it at all, and they don't know. Um, and so I just kind of keep them on their toes, and that's kind of how I do it, because that way I kind of pick and choose. And and I don't tell the kids this, but checking for completion versus checking for accuracy, a lot of times has to do with how busy I am. But I pick and choose how I do it to do it what's best for them. I mean, because some subjects like conversions, I need to check that for accuracy. I've got to see what they're doing, and I need to see where they're making mistakes. And so my grading kind of change and vary depending upon what I need to get done. So that's kind of how I work with that. All right. So another big thing there for being safe is being approachable. That's part of why I walk around the classroom. There are some days I'm tired and I do sit at my desk, but that usually is not as helpful in my classroom. My students will learn better and I will be able to pace better if I'm approachable, if I'm walking around the classroom and I'm checking on them. Because this is so great for my quiet kids who are never going to say a peep in class. I can check on them. I can give them one-on-one attention. I can do that. I can be approachable for them. And eventually by the end of the year, they're able to ask questions in class because they feel safe enough and I'm approachable enough, and it really helps that way. Because when it comes to pacing, this, you'll hear this throughout the summer with these summer workshops, I'm a firm believer. If you win their hearts, you will win their minds. When my students know that I am for them and I am for their learning, and that I'm going to take an extra day and slow down my pacing to make sure they get it. Like for example, if I say, hey guys, we're going to have a test on Thursday, and Monday and Tuesday, I'm just kind of like, ooh, they're not ready. And I make a comment like, hey guys, you're working hard, but we're just not ready yet. I'm going to push that back to Friday. The students then feel valued. They understand that I'm there for them and I want them to learn. And when they get that, when they see that I'm approachable, and when I'm walking around doing this classwork in class time, I start winning their hearts, and therefore I win their minds, which allows me to go faster on the back end. Once again, this student-driven pacing is kind of front-heavy. You're putting in legwork at the beginning, and it feels like you're going slow, but the whole idea is you're developing this foundation of knowledge, but foundation of them trusting you, foundation of them knowing how to work and use class time well and use homework well. Then when you need to go faster, you can, because you've got them on your side. They know you're there for them, and they've got the skills that they need to move on. And so really for me, that is the crux of pacing, is that we've got to do these things, that we've got to lay the foundation, and we've got to supervise that building process. We've got to watch it as we go along. That is so critical. And so what I want to talk about right now, so that's the main crux I want to talk about in terms of planning and pacing. And so what I want to talk about now is what I have for you as teachers to help you grow as a chemistry teacher. Is that for me as a chemistry teacher, you can start by growing nowhere, meaning just not do anything to grow, but you're here. That's not who you are. But then I kind of see a couple of processes that need to happen. As a chemistry teacher, we need to grow in content. We need to understand the content. And probably more so than any class, chemistry is a hard class for content. 60% of high school chemistry teachers are not chemists or don't have chemistry degrees. They're biology people or they're physics people. Or I've got a guy I know who's an elementary ed degree, but he's teaching high school chemistry. The content is hard. And so you got to grow on that content first and foremost. And then after that, you can grow in communication, that ability to communicate it to the kids. Because we've all probably had teachers out there who knew their content but couldn't teach it worth a lick. I had more than a few professors that way in college who were smart as a whip but couldn't explain it to me at all. And so that's our second stage of growing, is we grow in communicating to our students. And then finally, once we're really comfortable with the content, and once we're really comfortable with how to explain it to our students, and every willing student is able to learn, then that actually frees up a lot of your mind to finally let your creativity, that real, some of those things you were passionate about when you first got into teaching, those ideas start to be able to come to fruition because you've gotten the rest of this kind of figured out. And that's what I see as growing creativity. And so if growing in content is an area where you need to grow, and that's kind of where you see yourself at, then you can teach yourself as you go along. That's how a lot of people do it. They teach themselves, every night before they teach it the next day. I don't recommend it. Because I think most chemistry textbooks are really, really hard to read. That you need to have a chemistry degree to understand what the heck they're saying. If you want a good book, by the way, now I'll post a link somewhere on this, but Raymond Chang, his college chemistry textbook is one of the most readable and easy to understand chemistry books I've ever seen. He goes into a lot of the technical detail because it's a college book, but it's a great book resource to have. Raymond Chang, and I think it's literally just called Chemistry. You can find it on Amazon. And then online resources are, like, I've looked at Khan Academy, I've looked at Teachers Pay Teachers. There's a lot of mixed stuff out there. So what I did is, over this last 6 months, I put together an entire crash course to help on chemistry content. It is over 8 hours of videos. It is a workbook with a step-by-step key. It's office hours with me. All these resources to help you learn the content of chemistry so you can teach it better. Like I said, so I give you all the resources and structure you need to learn chemistry instead of having to do it yourself. Because the other difficulty with chemistry is, every school I was ever at, I was the only chemistry teacher. I never had a mentor teacher who could really teach me to teach chemistry. Now, an English teacher they can give you some basic teaching tips, but they can't teach you to teach chemistry. I'm a biology teacher. They can help a little bit, but they can't really teach you to teach chemistry. And that's what I want to do, is I want to help teach y'all how to teach chemistry. You heard that Southernism, y'all there? That's what I get for living in Mississippi. If you're in that second stage, if you're growing in communication, we've got this summer workshop series, and that's why I've got this. I want to help you be able to teach better and explain things to your students better. You can look at the other ones. If you're watching this on Facebook, this is the only one I'm going to stream to Facebook. I'm going to do, everything else is going to be basically for people who register. And you just go to teachinghighschoolchem.com/workshops, and you can register there. I'm really excited about next week, talking about just how do we help kids with weak math skills, and how do we help them? Because I think that's a critical area that they kind of get left in the dust, or they sabotage our class, and it doesn't have to be that way. And we'll look at that next week. But I also have a membership site that I've created called the Academy, where I'm giving you all of the resources you need. This is literally, I give you, I try to take away hours of your prep every week. Every classwork assignment, every homework, every quiz, every lab, every review sheet, every test, I give it to you. Then I also have instructional videos going through not just what is the content, but how to explain it to kids. Where do they make their mistakes? Where are the common areas where kids struggle? Hey, look out for this thing over here. Try this strategy here. But on top of that, I do weekly office hours, and I do check on people with emails and Facebook Messenger that if you run into questions and you run into an issue, I had a teacher this year who her school is just a crazy schedule, where they teach half day blocks for like 12 weeks or something like that. And that's a year. And I'm just like, oh, and so I worked on it with her one-on-one because she was one of my members in the academy. And I worked with her to help her get how to do that. All right. And so, like I said, unlimited support, office hours, everything. All right. If you're growing in creativity, if you're that, you feel you're that far, and this is really, the lounge is open for everybody. I've got a free Facebook group called The Lounge. I didn't do as much with it last year as I wanted to, but I want it to be a place where we as chemistry teachers have a place where we can share ideas and encourage one another, ask questions, and that kind of thing. It's a great place for those experienced teachers to kind of invest and help others. And so I've got a couple of deals for the summer. I'm not going to offer these every webinar, but I'll do them a couple times through the summer. But the crash course, you can save 20%. The crash course, like I said, it's a lot of stuff. And so if you try to take an online class or something like that, you're going to spend hundreds of dollars. And so with that coupon code, you get the crash course for $237. And then the academy, by saving $10 a month, that drops the price to $37 a month. And at $37 a month, that's a little over $1 a day. But I feel like the academy can save you hours a day. And same thing with the crash course. What I'm trying to do is I'm not trying to make money so much as I need to make money because, like I said, I left the classroom to do this. But the reason why I'm doing this is I'm trying to save you time. I love my family and my kids. I love my students. But students come and go. I get a new batch of students the next year. But my kids are always there. And it's so easy as a teacher for us to really lose our kids and lose our families. And, I don't want that to be the case. I want to give you the resources that you're not having to spend an hour studying chemistry so you can teach it the next day. I want to give you the resources so that you're well grounded and you still have time with your family and friends. I want to be here and watch my kids grow up. The last school I was at, we did actually have another chemistry teacher, and I remember sitting with him. I was talking about my kids, and he's just like, "Dude, don't let it slip away." I mean, he was an older guy. His kids were already grown. He's like, "I missed too much of my kids' lives growing up. I got so consumed with teaching that I lost my kids' lives." And that's what I want to be. I want to be a resource to you to equip you to be both a great teacher, but also to be a great parent, a great friend, a great spouse. And so that's really my passion for y'all. So let me try to find my cursor here. We're having technical difficulties at the moment. So my cursor disappeared somehow. So I'm trying to find my cursor here. There we go. All right, I got my cursor back. So now, if y'all have any questions about this or really about anything, I am going to be on to do that. So somebody had asked earlier about college credit. For this, no, I don't do that. Do I offer college credit for my courses that I teach? No. I haven't gotten that all figured out yet. I want to work with one of our local colleges to get some college credit going on for these things, but I've not yet gotten that figured out yet. If somebody asked, Connie asked, are your activities paper and pencil or computer activities? These are paper and pencil. These are things you can print out. They're all PDFs. I'm a firm believer that skills like nomenclature and so on are best done by writing. Um, Kind of my addendum to that, if you're a school that does technology, if you have the newer iPads that you can write on with a stylus or a pencil, I love these. This gives me the organization of digital plus the processing of writing, and I love that. And then somebody asked, do I have a single page of the Academy? Yes. If you go to teachinghighschoolchem.com/members/covalent, so that's teachinghighschoolchem.com/members/covalent, then that will give you have access to that page. And it gives you the video and everything that I have for that. Let me see if I can pull it up real quick to show you what that looks like. All right, so this is my covalent nomenclature page. Like I said, it's teachinghighschoolchem.com/members/covalent. And so I give a little introduction of, hey, these are things you need to know before you get into this. A little self-assessment quiz, kind of how I overview the pacing. And then teaching notes, slides, videos, then student materials, quizzes, and then Vesper, polarity, and then finally review and test down here. And so I've got all of those there as well. Okay. So let me read Sarah's question about PowerPoints real quick. Yeah, I've run into the same problem, Sarah, in terms of kids writing down everything. What I've done with that is I limit what I write on the board. I try to teach them that same skill of, hey guys, in college, you're going to have to write faster. And I try to teach them shorthand. And I've actually gotten to the point that when I write things on the board, I write them in shorthand. Like I start doing RxN for reactions. I do stoic for stoichiometry. Like I'll try to teach them some of those skills in my notes as I'm doing them. The PowerPoints that I have for members, I didn't do that. But I'm also I try to give them the high points. Like the things that I want them to write down, that's what I write down. And then other things I say out loud and explain it as I go along. And it's always that it's give and take, trying to teach kids how to write notes. It's frustrating. I definitely get that one. I have definitely run into that over and over again. So like I said, if y'all have any other questions in the question area or in the Q&A or chat area. And so what I'm going to do, I went a little faster than I expected there, which is good. So these will be hopefully 30 to 45 minutes. Next week, I'm thinking going to probably be more towards the 45 minutes plus the Q&A at the end, just looking at the time. Because I want to show you all some methods that work next week for teaching kids with weak math skills. How to take it from math, where kids all freak out, it's like, I can't do math, and try to make it down into something that's more about what they can do method-wise. And so I'll try to bring that down. So just kind of quick overview of what I said earlier. Planning, in my mind, is about what type of class you're trying to build. What are you building towards? Are you building to graduation, prepping them for college chemistry or AP? And then you got to plan accordingly. What do you think is going to be the most important? If you're trying to prepare your kids for college chemistry, the most important things are nomenclature, reactions, and moles and stoichiometry, what I call the big three. And then we kind of plan everything else around that. And that's kind of how that goes for me. And then, pacing for me is where my kids are understanding. And really, I think the most practical tip there is just assess as you go along. Use that class time. Because it's amazing what that communicates to kids. I'm thinking about a girl I had a couple years ago who she started off the year kind of in the upper C range. but by interacting with her and encouraging her and checking in on her, and then also just kind of giving her a good person to sit next to kind of help and bring her along, she was making A's by the end of the year, and so and it was so exciting to be able to tell her how proud I was of her, and then to be able to catch her mom in carpool, because she wasn't driving yet, and be able to catch her mom and be like, I've seen her grow this year, and I'm so excited to see that growth in her. It's amazing what that does, for a kid. When they know that you're for them, it makes a big difference. So, if y'all have any other questions, I'll be on for the next little bit of time. Um, and hopefully I'll see y'all next week. Really enjoyed it. Thanks.